Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss another one topic, the velocity distribution for turbulent flow in terms of average velocity. So up to now, we have discussed many different type of flows like laminar flow, turbulent flow, transition flow, and also you discuss about the laminar sublayer flow and what is the shear stress in that turbulent flow is there. And we have considered the shear stress for viscous flow and shear stress for the turbulent flow. And also you have derived many equations in that. So let's see here the velocity distribution for the turbulent flow in terms of average velocity. So while talking about the average velocity, we need to consider the u bar actually, or we can consider the v bar. Whether you are giving the notation for velocity v bar or u bar, that depends upon us. We can consider that. And while discussing this one, so how to calculate these things? Now we can identify, we can calculate the average velocity or velocity from the total discharge, from the total discharge of the fluid flow. So we know that the total discharge is nothing but Q, and we know that continuity equation is Q equal to AV, and from V, like means from velocity, like the total discharge, we can identify like V equal to, we can write Q by A, and here the V is nothing but, we can say the average velocity. From that we can calculate. So V bar or U bar equal to, we can write Q by area, the total discharge by area. So to identify this velocity distribution for a turbulent flow, and we know that turbulent flow is nothing but, this is a high speed flow is there where velocity is very high, and for that, to identify this equation or to understand this theory, so I have taken a pipe, a circular here pipe is there. So in this pipe, the liquid is flowing, and this is the flow of liquid. So the flow of liquid here, suppose a velocity u is there, and in that I have taken a small elemental ring here, a small elemental circular ring, what we have taken here, though it is showing like a rectangular type, but it's a circular ring what we have considered. And this is the center line of this pipe, which is with a radius of r, and the circular ring which is placed here with a distance of y from this wall of this pipe, okay, and that is situated with a distance of r, small r here. So we can write y equal to what? From this point, if you see y equal to, we can write the capital R minus small r. So here we can write y equal to capital R minus small r. So capital R is the radius of the, you can say, pipe, and this is the small r, which is the circular ring which is situated, that is situated with a height of y from this wall thickness, we can say, or wall of the pipe. So anyway, so total discharge here, we know that D, as I written, Q equal to AV. So we can write the total discharge, or dq, I can write in terms of area of the ring into velocity. Area is here, area of the ring into velocity, so that is area of ring into velocity. So here again we can write this area of the ring is what? The area of the ring we can write 2 pi r dr, because it is a circular one, and circular object, what the area we can be considered. So let me write here dq equal to, this will be 2 pi r dr, 2 pi r dr into the velocity. Here v you can consider, or you can consider u. So let's take u here, because in the previous videos and previous derivations we have considered the u term is there. So this is about the dq, because it is a small one, that's why we have taken the dq. Now if you let calculate the total discharge, let calculate the total discharge. So this one we can calculate by integrating this term, q equal to integration of dq equal to integration of, this is the integration from which point to which point we need to consider. Now from this surface of this wall, or from surface of the pipe up to the center line or center axis of this pipe, you can say. So that means from lower limit, upper limit 0 to r. The total distance is r here. So again, this one we can write, this is 2 pi r dr, 2 pi r dr into u. So this one we can give a equation 1. This is about the equation 1 for the discharge term. Okay. Now, so here this pipe may have, you know, two different types may be there. One is a smooth pipe, another one is rough pipe. We have seen already previously. So let's see, consider the first condition for the smooth pipe. For the smooth pipe, what will be this average velocity? For the smooth pipe, okay, it's very simple concept actually. We need to find out the average velocity when the flow is turbulent and the velocity distribution through a pipe. Okay. Now for a smooth pipe, we know that we need to go back to the previous theory and previous derivation where we have derived the velocity distribution for the turbulent flow. And for the smooth pipe, there we got the equation like u by u star equal to, the equation was 5.75, and this is log 10, and this is u star y by nu plus 5.5. This 5.5 will become for the smooth pipe, and for the raw pipe it will be there, you know, y by k will be there, and here 8.5 will be there. That is the difference, and remaining all will be same mostly. So now here, if you see, here we have the value of y equal to y, because total height what was there. But here we are taking the average velocity, and on place of y we need to consider this value of r minus r here. So what we'll do here, I'll just put the value of r minus r here on the place of this y. Then we'll see what is the equation. So what I'll write here, so I'll write u equal to one more thing I'll do, I'll just take this u star to this to in the right hand side. So equation will be 5.75, and this is log 10 u star in place of y, let's write r minus r divided by nu plus 5.5 bracket close, and this u star we can write here this one. So this is about the value of y after putting in the equation this. Now what we'll do, we'll just see, this is u value what we got. Now if you go back to the total discharge equation, u value is there. Just we put this value in this total discharge equation. So here we can give this equation 2. So it is not necessary, we can mention it, no issue. So let's put the value of u in the total discharge equation q first in the equation 1. Then what will we get there? Like we will get q equal to, so this is equation like integration 0 to r. So let me give it this square bracket here, 5.75, and this is log 10, and this is u star, and this is r minus r nu divided by nu plus 5.5, and this is u star is again there. So u star, this is all of u. What about this again, 2 pi r dr is there. So here we will multiply 2 pi r, this is dr. Now this is the discharge equation after putting the value of u in this equation. Now we need to see what is the average velocity will be there. We won't solve all these things because it is difficult to solve and we won't get any final solution type. I'll show you that after integration what the final value will be there. And as I told you that average velocity equal to, I can write average velocity equal to what we can write here, now q by a. So already q is there here, so now I can write the average velocity u equal to q by a, and here a is nothing but we can write this pi r square. Okay, pi r square we can write, and this q value, what is the value here, just put this equation and we can write the area pi r square. So let's write area pi r square, and this q value what we got here, just to multiply this, means 0 to r, this is square bracket, again just same equation, just need to write 5.75, and this is log 10, and this is u star r minus capital R minus small r divided by nu, this is plus 5.5 bracket close, and again u star into 2 pi r dr. So this is all about the equation of this u bar. Now after integrating these things, okay, finally we'll get the value actually. This now see, all these terms are there, few constant terms are there, and few, like, integration 0 to r will be there. So this r equation, r value will be there, and here r dr is there. So now I'll just write one more term, final one. What I'll do here, I'll just take this u star what is multiplied already here previously, I've taken from here to this side, just I'll take to other side here, like left hand side. So I can write u bar by u star equal to the final equation, actually what we'll get here, that I'll write here after solving all these things. Okay, so we'll get u by u star, and this is 5.75 log, we'll get here 5.75 log 10, and this is again u star is there here, u star is there. Now u star is, we can write u star r by nu plus 1.75. Okay, so this is the equation we are going to get after integrating this equation in the smooth pipe. This one we can give equation 3. Okay, now similarly this is for the first condition. Similarly we need to go for the second condition, or that means second condition in the sense for the rough pipe. In the rough pipe also, again we need to see the previous equation what we have derived for the smooth pipe condition type. So there, yeah, let me write here, this is the second condition for rough pipe. For the rough pipe, what are the velocity distribution equation we got from for the turbulent flow, that we need to check it once. So see, this is the discharge equation is 1 q only, and for the smooth pipe, this was the derived equation what we have already previously got it, this equation. Now this value we just kept on this in terms of u, because u is there. So that value of u we kept here. Okay, now the next is for the rough pipe, what is the equation? Again we need to check it the previous value. Here I told you u by u star will be there 5.75 log here y by k will be there plus 8.75 is there. So that is the only difference. So I can write for the rough pipe the velocity distribution of any point. We can for the turbulent flow we know that u by u star equal to, and this is 5.75, this is log 10, this is, yeah, this is, you can write y by k plus 8.75. Okay, now what I'll do, I'll just put the value of y equal to r minus r, means capital R minus smaller what we got here, the same value, the value of y I'll just put in this, because previously we have the center line point. Now after putting the value of y equal to r minus r, and this u also you can take it to other side, or you can keep it here one side. So directly write u equal to u star, okay, into 5.75, this is log 10, and here r minus r divided by k plus 8.75. So this is 5.5, here it is actually 8.5, not 7.5. 8.5 only. Okay, now what we'll do, this u value we got here, again we have to go for the total discharge equation q. So like from this, what is the total output will be come out from this pipe. Okay, so that means the q value, will just put the value of u in the q. So in the q equation we know that q equal to integration of 0 to r 2 pi r dr into u. Okay, so the same thing we can write, integration 0 to r 2 pi r dr into this 5.75, this is log 10, and this is r minus r by k plus 8.5 and into u star. This is about the equation what we got. Now we can write these things, like, you know, we can derive this, or we can directly write the average velocity, because in the previous also what we have seen, the average velocity we need to calculate. So average velocity we can write this way. Okay, so here also let's write the average velocity. So the average velocity u bar equal to, we can write q by a. So this q by a is nothing but, q value is already there, so, and a is, we know that pi r square, so right here directly 1 by pi r square, and this integration 0 to r and u star, let's start from u star here, and this is 5.75, this is log 10 bracket r minus r by k, and this is plus 8.5 bracket close, and the equation is 2 pi r by dr. Now again integrate this equation, then finally we'll get the average velocity, and again let me write, after integrating the average velocity, what we'll get here, average velocity, and this u term, u star, the shear velocity, we can take it to out and just divide here. Similarly what we have done in the previous case, similarly we can do u bar by u star equal to, finally we'll get this constant term, like take it to outside, 5.75, this is log 10, and this finally will be there r, okay, r by this k is there, r by k plus 4.75. Okay, so this will be our equation. Previously what equation we have given? Equation 3. Now we can give equation 4. This is our final average velocity for the rough pipe condition. Okay, so this equation we can derive in such a way, like you can go for this log 1 by 1. We can do 5.75 log r minus 1. Again a by b is there, so a minus b. So 5.75 log again k. So again we can derive, integrate of all these things individually 1 by 1, and this constant term is there. So then after solving all these things, you'll get, this is the final equation. Similarly, what we have got here, this is the average velocity, and from this we got this. Okay, u bar e by u star equal to 5.75 log 10 u star r by nu plus 1.75. So here just slight change is there, so that one we got here. U bar by u star 5 equal to 5.75 log 10 r by k plus 4.75. So this is about the velocity distribution for turbulent flow in terms of average velocity. Very simple thing. Just average velocity, we know that how to calculate. We know that velocity equal to discharge by area. Or so average velocity we can see from the discharge term only we can able to calculate. So what is the total discharge from this pipe? So by the area. So discharge term we know that we can write q equal to AV. So area 2 pi r dr. Area of this pipe, circular ring pipe, is 2 pi r dr into the velocity of the fluid, and just total discharge equal to integration of this 0 to r, like from here to here, what is the distance is there, 0 to r, and this is main equation. Okay, this will be applicable for the smooth and as well as for the rough pipe also. So for the smooth pipe, what was the equation we have got previously? Equation of velocity distribution for the smooth pipe in the turbulent flow. So this equation we got previously. Just from that we just taken the value of u, then we kept the value of u in this discharge equation. Again a q value we got, and finally we have written the average velocity. Average velocity u bar equal to q by area. So q you got here, this value by area pi r square. Okay, now pi r square value, just you what we did, u bar by u star. This u star we have taken to the left hand side, and remaining things we have just integrated, and we finally got this equation. Similarly for the rough pipe also, similar concept. This equation was derived previously. U by u star equal to 5.75 log 10 y by k plus 8.5. Okay, and a similar method, you keep it one side, you start take to other side and put the value of y equal to, here you can write one more point, y equal to r minus r, though I have written in the first, that's why I'm not written here, and just put the value of u in the discharge term, q equal to AV, and again average velocity u bar equal to q by a. So I hope you understand this equation, how to derive this. Still, if you are having any doubt, query regarding this, you can give a comment on the comment box. Thank you all.